So in this meeting, we'll be considering chapter 3, methodology. And when we talk about methodology, what do you have in mind? I'd love to hear from you, everyone in this meeting. What comes to mind when we talk about methodology? So let's get your views.
Hi, Doc. Good morning. Good afternoon.
A very good afternoon.
Yeah. So, in my own aspect, for methodology is just like the technique you use in accomplishing your results. I can just put it like that.
Okay. Just mentioned methodology. You said techniques.
In completing your results.
To achieve your results. Okay, so do we have any other view? Any other view? I'd love us to speak up. I know you must have something in mind. You already completed your undergraduate program, you had your project. So what was your methodology all about? So do we do name calling?
So,
Okay.
for me, I think it has to do with the process, the method you intend to apply towards your research. The method you intend to use to achieve the results.
Okay, you intend to use to achieve your results. So I think something is common with what Richard and Rachel just mentioned, results. Okay, so when you begin your research, do you have an idea what your result should look like? So
Yeah, like when I was computing for when I was trying to work on my mini projects, I was having a direction of what I want to attain in that project it's just like a build up on what has already been done. So I was trying to look at what I can do to put in more of the results that has been already achieved. So it's an intention of looking at the end results, that what will happen if I put in this process, will it come out in this with the result I'm expecting? So
okay.
something like that, yeah.
Okay, that sounds good. So you're right. I just want us to put things in perspective. So what if we replace this result with aim?
Okay.
So does this sound a little broader than results?
I think it's even more closer, more
Okay.
direct. Yes, more direct.
Okay. So I'd love us to think in terms of the aim rather than the results. Okay,
The
because
results. Okay.
yes, the results are those uh, 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 are the effects of our research, right? So when we talk about the output, so after testing your methodology, you should get results, okay? But the challenge is the result may be as close as possible to your aim, or it may even deviate or diverge. Okay, so if the result comes to being the outcome of your research, so I'd rather suggest we look in terms of, or we view the methodology in terms of the aim, because the aim is the goal of our research, right? Isn't it? That is what we have in mind. And that is what we want to achieve. And from the aim, we give birth to some objectives. to say, well, these are the things we need to do to achieve the aim, right? So that makes our research engagement pretty easy and straightforward. Now that we have our aim and objectives defined, then we now want to test the appropriate methods that will be able to achieve our objectives. Does that make sense?
Yeah.
Okay, so it means that if we are able to achieve the objectives, then we should be able to arrive at the outcome. But what if we don't arrive at the outcome? Have we wasted our time? Not really. All you need to do is to document your observations and then explain why you couldn't achieve that outcome. Okay, well, we'll come to that. So how do we document our methodology? We have a couple of steps and all of that. But who can tell us the reason we have a chapter on methodology? Why do we have this chapter? Who can tell us? Why do we have? Go ahead, please.
Okay, I think it's just to like highlight the process you used while working on this particular project you want to do. So therefore, you are just trying to highlight your process, the methods, the way in which you have used to work on your projects.
Absolutely. That's quite brilliant. Do we have any other addition to this? We have Omar Ali, Sajini, Israel, Ola Paul. So can they also contribute, please? Rachel is also here.
Good afternoon, sir.
A very good afternoon, Omar Ali.
Yes, sir. I think the main reason for methodology is the steps or where you is the main body for the project or the research, because that's where you analyze, you write how you collect your data, you interpret it, and the procedure, the steps you use to conduct the studies.
Okay. So, because that is the main thing, right? That's what Umar just said. Do you have any other addition to this?
Yes, sir.
Okay, go ahead, please, Israel.
Okay, the addition I have is that the reason for it is that it makes the project easily replicable, because a lot of the research we do now might not even be useful in our generation, but a time is coming when they may need to replicate it. So it's yes, sir.
Beautiful. Yeah, I think that summarizes everything. So we want to ensure reproducibility. All right. So if your methodology does not ensure this, then you do not have a good documentation. That's the goal. So we want to replicate. Just like you said, we want to be able to replicate what we have. So no matter how brilliant your idea may be, the goal for having the documentation of methodology is for us to be able to reproduce what may have been done. Okay? Does this make sense, please? Does this make sense, please? Hello?
Yes, sir.
Okay. Now, yeah, go ahead, please. I think I had Rachel say something.
No, but I was just responding to your question whether it makes sense.
Okay. So now for us to be able to position this idea, then we want to mention the possible steps. Okay, so what are the possible steps for methodology? If we want to have our methodology going, so what are the steps we should have in mind? How do we sessionalize the chapter? Okay, so I want to believe I'm talking to experts. So tell me. So can you mention some of the interesting steps? We should.
Yeah, for like if someone is running a project, you want to look at the design of the
Okay.
project.
Mhm.
So you are actually first, I think that should be the first thing. How do you want this to be implemented? So you look at the design, then gradually you now want to go to the next phase of possibly I think you can now propose if there is other choice of design that could be added to that, I mean, or another choice of things that could be added to that design so that it could look more befitting for others to use or to implement that project. So after, then you could now examine how this could go a long way to benefit the individuals that want to make use of it and where it could be used. So that's my own take.
Okay. So any other contribution? We have design alternatives benefits from Richard. So what should we look out for?
Yes, my contribution is you add data collection, sampling, and data analysis.
Okay, data collection, data sampling, then we have data analysis. Okay, so when we look up all of these, so can you just give a little um, an additional hint? What do you mean by data collection? What do you mean by sampling? What do you mean by analysis?
Yes, the data collection is the survey, the observation, experiment, and document analysis
Okay,
process of selecting a.
I think where are you? Go ahead, please. Is Mr. Omar Ali still with us?
From, hello, sir.
Yeah,
Can you hear me?
yeah, we can hear you now.
I said the data sampling is the process of selecting a subset from the main research. Then the data analysis, you perform your quantitative and qualitative analysis.
Okay. So it could be either quantitative or qualitative analysis. Okay, go ahead. Are you done? Okay, are you still with us? Okay, I think Mr. Omar Ali just muted. Now, can you all hear me still?
Yes, sir.
Okay, perfect. So we have design alternatives, benefits, then data collection, data sampling, data analysis. Now, this is about it. Okay. So generally, we want to look up the research design, right? So is this a qualitative research? Is it a quantitative research? What kind of research are we conducting? So we want to align whatsoever research model we have to our research objectives. Then we want to tell the sample space, the population, okay? What kind of data are we going to be dealing with, and then want to justify that particular data, okay? And then we talk about the tools we want to use, okay? Because for us to be able to reproduce this idea, this solution or this method, then we should know what was used, in the experimental setup. And then we collect the data, then we analyze the data using some statistical models. Well, good enough. We have quite a number of solutions or tools or softwares, SPSS is there, MATLAB, Python, and so many others that could be used to analyze data built on or based on certain algorithms. And then we want to justify our claim by validation. And one more thing we also want to include in this description is the ethical consideration, okay? So we don't just want to conduct a research that will infringe on anybody's rights or safety. Good. Now, your methodology, or better said, the structure of your methodology may vary depending on the type of research. Now, good enough, you have mini project where you have to develop a prototype and then you have main research. Now, you realize that the structure of your methodology for your mini project is going to be different from your main research. Do you agree with that?
Yes, sir.
Okay, why did you agree? Why?
Okay. For because you've instructed us, the mini project is just like you are building on a design or an existing design. So your methods might not be as much as what you've used in implementing your results. So definitely it will just be like maybe you just go through two processes or maybe one or two processes to accomplish a result. But in the aspect of the main research, because you are computing so many processes, an existing research has been done, but you still want to involve some other uh, methods, probably what you feel that you've gone through another process, not yielding to the results, but you feel like, okay, when you had this method, this this will also take an alternative direction to what the person has already done. So it's the process might take another two or three more steps to accomplish or to go to tend towards a particular aim. You understand? So
I get your point, but don't you think that reason applies to both mini project and main project? Because you may want to improve on what had been done previously, probably a particular design, a solution, and now you want to retweak it. Now we used to have band antennas. Now we have smart antennas, right?
yeah.
Yeah. So there was a time we used to have the dual band antennas for coverage in telecom that just had the dipole for the 900 megahertz and 1800 megahertz. So you could do your um, uh, electrical and mechanical tilt on it. So when you go up the mass and all of that. So you see that for the band antennas. But At some point, we had tri-band where we had the 900, 1800, and 2100. So it could serve for both 2G and 3G. And now we even have improved designs. Now that we are dealing with 4G and the likes, even 5G. So you now see that you may have that in mind as a prototype for your mini project. So don't you think the idea you have about your main research will also apply to the mini project at that time?
Yeah.
Okay. Okay. So I think I just boxed you to a corner, right? Well, your idea is very valid, is very, very much valid. But I want us to consider the structure of your methodology based on the type of research. Okay? So I want to, my argument is that the structure of the methodology may vary. I'm not saying it will vary. So this is conditional, right? May vary depending on the type of research. Okay, so if we want to consider some types of research, okay, just before I go on, I think someone is missing in this class. There is this other lady, is it Sarah or something there about? She's not here.
Yes, sir. She chatted us that she's in meeting now, so maybe she'll follow up with the videos later.
Okay, that sounds good. It's okay. Now,
Yes, sir.
so now we could look up some of those research types. Now, I'm not saying these are the only types of research, okay? So I'll say this is based on interest. So I'm going to be running through this classification based on interest, okay? So the first I'll say is experimental research. So another is computational research. Then another is design-based research. Okay. Now, I want to assume that your main research may take this format. Okay. Why your mini research is literally design-based. Okay. So it means that your main research may be experimental, it may be computational. But interestingly, your main research could also be design-based. So it depends. For now, do you agree with this line of thought before I progress? Do you agree with this? We have Ola Paul. Do you agree? We also have Israel.
Yes, sir. Yes, sir.
Okay, now there's something I want to push to you. Now, for research, you don't have to say yes to everything or yes to everything. Because we must come up with a philosophical, yeah, sorry for that, a philosophical idea about whatsoever we want to do. So there should be a philosophical idea that guides your research discipline. That is where you are able to critique. Okay? So you may not agree with this. You may agree with it, but there should be a valid reason for either agreeing or not agreeing. And the word valid in this case is relative because we must define what is valid to say that is valid, isn't it?
All right, sir. Yes, sir.
Okay. So now let us look up experimental research. Now, in my own view, experimental research focuses on empirical data, right? Yeah, we want to deal with empirical data. Probably some controlled laboratory experiment. Probably you're also conducting real-world testing, right? So no, that is experimental data. Let's assume you decide to conduct drag testing, where you have to collect some signal levels, some received signal strengths, data, and all of that. Probably you want to develop a propagation model that will inform some kind of antenna design for that environment. So what model should we use to predict the signal level in that terrain? So that may be that. So then you'll be conducting experimental research because you have to play with empirical data. Now, how you structure your methodology will vary. How about computational research? And here you want to probably perform some kind of numerical simulations, right? You want to do some kind of mathematical modeling. Like the lady that want to work on antenna systems. I want to look up the emerging MIMO-based technologies. Okay, so you are going to be doing some kind of mathematical modeling. Okay, so you want to look up what is happening within that spatial domain when we have so many antennas spaced relative to themselves. And so what will happen to the system? You're looking at diversity. So you are literally going to be doing or conducting computational research. Okay? So probably you want to, let's say, algorithm development. Okay? Even machine learning. So all of these have to do with computational research. And the way you structure methodology will be different from how you will structure your methodology if you were conducting, if your research was experimental. Is this clear, please? I'd love to be sure we are all on the same page. Is this clear? Okay, I think everybody checked out of the class, right?
Sir, you in the first one you said experimental talks about the real world testing. And for instance, if you have an algorithm that you want to develop on a research, and actually it tends towards the real world, can we also say we are both uh, taking the two processes of both experimental and computational together?
Well, I don't think so, because at that point, you are literally developing an algorithm that will be tested.
In
Okay?
the real world, yes,
Yeah,
that
but
okay.
here in experimental research, it's more like, when we have some kind of controlled laboratory experiment.
Okay. Okay.
Okay? So you are literally conducting an experiment where you have to either measure something, collect data, you have an experimental setup where you have to gather data, you are interacting with actual physical data, which you end up cleaning up before you can even use. So it means you are in the business of collecting real raw data. Let's say someone conducting research in wind, let's say renewable energy, and then you have to collect meteorological data. Okay?
Okay.
So that's
Yeah.
experimental, because you are dealing with empirical data. So the way you structure your methodology is different because you will be talking to your data, analyzing your data, and then interpreting that data. Whereas in computational research, you are coming up with a model for which you develop some governing equations to drive what you are trying to propose. So you're going to be performing some kind of numerical simulation, some kind of mathematical modeling, and all of that. That's computational. I don't know if you
Okay.
get the difference.
Okay, but sir, what about if like you collected such data, for instance, like from a meteorological center, you collected such data and you want to like manipulate the data by modeling a mathematical form model for such data. Is it not still more like you are,
Computational.
yeah, oh, okay.
Now it's like what you're doing is looking more like computational, right?
Okay.
I think that's where you
Because in the design of the methodology, because you actually said that the process for the methodology of experimental research might be quite different from the one for the computational research. So I'm trying to look at a way that possibly if there is a way that we could meet up a point where both can be like on the same level, but they might not be of the same methods or the way you put it down in your research
Okay.
book.
I get what you mean. So now as we progress, we are going to see where they differ.
Okay.
Okay, yeah, we're going to see where they differ. Okay. I get what you mean. Probably at the end of the day, you want to come up with a mathematical model from
Yeah.
your empirical data.
Data. Yeah.
Yeah. So we'll see where they all meet. And
Okay.
then how about your design-based research? So it literally focuses on system design, right? Prototyping, the system design. Then we have to prototype, right? Prototyping. And then afterwards, you want to look up the performance evaluation of what you have designed. Okay. So this also have its own framework. So, I'd love to just run through from experimental research to computational research and then design-based research. So you know how to go about your methodology. And then hopefully next week, next week we may want to look up results and all of that. So once we are able to look through how all the chapters should be organized, then we'll begin to discuss our research proper. So I want to believe by then your chapter 1, chapter 2, and chapter 3 should be ready. Okay, ready. If not ready, it could be ready, but in progress, right? Is that okay, please?
Yes, sir.
Okay, so let's look up methodology for experimental research. Okay. So how do we structure this? So, well, now the subheadings are not statutory, okay? So I wanted to take note of that. We just want to play with these subsectional headings just to guide what you'll be doing. So you're going to be giving your subheadings, the title of your subheading based on what you're working on, okay? So let us look at, okay, let's not call it 3.1 or 3.2 or whatsoever. Let's just say one of the subheadings to begin. We want to call that introduction, right? So one of the major things we want to begin with is the research design and approach. Okay, So here, you want to clearly define the experimental nature of the study. Okay? So this is where you define it. Okay? So if you are conducting some kind of controlled laboratory experiment, for instance, so you want to mention how it is conducted in a controlled environment where variables can be adjusted, okay, and all of that. Then your feed experiment, so it means it could be some kind of controlled laboratory experiment. Then it could be some kind of field measurement, like I mentioned earlier. So probably you want to conduct drive testing and collect field data. So you are literally conducting a real-world environmental check. Okay, then this could also be some kind of comparative study. So here you are comparing different systems and processes or techniques. But it's in this session you get to tell the reader what you are doing. So you want to define the nature of the experiment you are conducting. Is it controlled laboratory experiment? Is it field measurement? Is it a comparative study? So once you do that, the next thing you want to do is to provide justification for your choice. If, let's assume you chose feed measurement. Why feed measurement? Why not controlled laboratory experiment? Okay. Do you need an anechoic chamber for your testing? It depends. Okay. So why is it fit test? You know, why is it not comparative? So there must be that justification for it. Probably the nature of the experiment or the nature of the research and all of that. Then afterwards, you now go on to describe the scientific principles or engineering theories guiding the study. So now, why you do that, you also want to tell whether the study follows a comparative, causal, or exploratory experimental design. Okay? And what is comparative? Let's write this. So what is comparative experimental design? Now, then if we say it is causal, so what is causal experimental design? And if it's exploratory, what does that mean? So you want to tell which of these. So if we are talking comparative experimental design, it literally compares two or more groups to determine the difference in outcome. Okay, why for causal? Here we are literally looking at cause and effect. Okay, so you want to establish the cause and effect relationship between variables. So, and here you are looking at manipulating an independent variable by measuring its effect on, let's say, a dependent variable, you know, and then that's it. So you are literally investigating the cause and effect in terms of this measured data. They could also be exploratory, okay, in that you just want to use prior or existing knowledge uh, uh, to validate whatsoever you are doing. Okay. And then the idea is not to necessarily improve on existing knowledge. You just want to provide more information. Okay. You just want to gain more insight. So the exploratory experimental design literally helps in identifying certain patterns, relationships, and some other metrics that should be investigated. So you want to tell in terms of justifying this claim. So once you're done with that, then you can move to the next session. Okay, so it means your research design and approach have been taken care of. So you want to now move on to the experimental setup and procedure. So this is where you talk about the laboratory and fit setup. So you want to provide a detailed description of the experimental environment. And here you want to include schematics, the diagrams of the experimental setup showing the key components. You want to document necessary precautions and safety measures, okay? So we want to see how you set up this. Now, don't forget, the idea is to replicate, to be able to replicate. So someone should be, once someone picks up your document and read through your methodology, they should be able to replicate or reproduce what you have done, right? So that's the goal. So you want to provide the laboratory setup. And another thing you want to mention here is the equipment and instrumentation. So you want to specify the equipment you used in measuring data. Is it a oscilloscope? Is it some kind of pressure transducer? What is it? Then the computers and softwares you use for data acquisition. Did you use MATLAB? Did you use LabVIEW? Did you use Multisim or whatsoever it is? You know, did you use Spice or whatsoever? Now you want to mention the tools you used, okay? And then another thing you want to talk about is the experimental procedure in this session. So here you want to provide the step-by-step protocol for conducting the experiment. How did I set up my tools to collect the data? You have to describe the control variables, that is the dependent and independent variables, and how they are maintained. Then you want to outline the data collection steps, the number of trials, the time intervals, the measurement techniques, and all of that. Is this okay? Are we still together?
Yes, sir, we're together.
Okay. Now, then once you're done with this, another session will be the data collection method. So you want to specify the type of data. So is it quantitative data, such as numerical values, signal readings, voltage levels, and so on? Or is it qualitative data, such as observations, behavioral responses, and so on? So you have to specify the type of data collected. Then in the data collection method, you also want to explain the sampling technique, okay? So is it random sampling, systematic sampling, stratified sampling for multiple test groups and all of that? Then one other thing you want to mention is that you want to also describe the data acquisition technique, okay? So how did you gather this data? Is it through Google form, through manual login, through an automated system where you had to set up the equipment and then it recorded it into a certain file, and then you had to convert to another file to be able to generate the data, you have to mention. And then you want to provide the uncertainty analysis to estimate measurement error. So once you're done with this data collection method, then the next session you want to document will be the data processing and analysis. So in the data processing and analysis session, you want to document the data preprocessing, where you explain the method used to clean the data. I mentioned that earlier. So we talk about preprocessing. How did you clean the data? How did you filter it? How did you organize the raw data? Then you also want to address signal noise reduction methods and what have you. And then you also want to mention the statistical and analytical methods used, okay? So you want to define the statistical tools. So did you use mean? Is it standard deviation? Did you use ANOVA? Did you use a variance? And all of that. Is it t-test for comparing groups? Did you perform regression analysis for trend identification? Now, you want to tell all of these in terms of the statistical tools. And also, you want to mention the error analysis method you use to determine uncertainty in measurement, okay? The confidence level. You also want to discuss the hypothesis testing. Okay, so those are the things you literally deal with. And now you realize that everything we are doing here talks to data. Mr. Rabo, is this clear?
Yeah, yes, sir. Yes, sir.
Okay, so we don't confuse this approach for computational technique. Now, and then afterwards, you can go up, or better still, begin another session on testing and validation. Okay. And so there you want to describe procedures for repeatability or reproducibility tests to ensure consistent results. So if we have to perform this experiment again, will there be any modification? What should be done? Now you document the key performance metrics, okay? In terms of efficiency, reliability, stability, accuracy. You discuss the potential limitations and sources of error, okay? In this session. And once you're done with that, you can go on to another session where you have to now discuss the ethical and safety considerations. Now that you are dealing with data, there is data privacy law. So you want to ensure it has not been violated while you conducted this research. Some of the data you get to use may be industry-based. I hope it's not going to affect their operation. Did you seek their consent before using their data? So you want to describe compliance with safety regulations and laboratory protocols. We have the ISO, the IEEE, and some other standards. You also want to ensure adherence to ethical guidelines. Okay, let's assume you are collecting human data or animal data and all of that. Then once this is done, then you can have the final session on summary, where you recap some of the key experimental setup, and then you justify their importance. So this takes care of experimental research. So I'll quickly run through the methodology for computational research, because most of you will be doing that. Methodology for computational research. So we start also with the first session where we have to document the research design and approach. Research design an approach. Now, the key difference here is that you want to describe the computational methodology. We're not talking data now. So here you want to describe the computational methodology. So is it simulation based? Is it mathematical modeling? Is it numerical modeling? Is it a finite elements method or analysis? Is it machine learning? Algorithm? So you want to mention the computational methodology used. Then afterwards, you want to justify why you chose the computational approach. Okay? Why is it preferred over experimental techniques? So you want to provide a justification for that. And afterwards, you can move on to another session or subsession, which is the computational model development. So here you begin with the mathematical formulation. So this is where you literally present the governing equations. And the theoretical models. Okay, so this could be differential equations, there could be Laplace transform, it could be Navier-Stokes equations. It depends, okay? So the mathematical modeling of the idea you are trying to present will now be presented here. And afterwards, you want to define the initial and boundary conditions, okay? Then you also want to justify simplifications made for computational feasibility. You want to discuss the impact on accuracy and computational efficiency and the likes. So once you've done this in terms of presenting the mathematical formulation, which would extend to quite a number of derivations or deductions, because you have to start from the first principle, okay? Then you now move into another session, which is on algorithm and software implementation. Okay, now that you have developed the system of equations, how do we implement them using some kind of algorithm and some kind of software? So if you've been able to develop a system of equation to address this problem, then you should be able to generate the algorithm, okay? So in this session, you want to specify the computational tools you want to use. So we need to know, specify the computational tools. So are you using MATLAB? Are you using Python? Are you using COMSOL? Are you using ANSYS? There are so many of them, okay? There are so many, depending on what you want to do. Then you now want to also describe the numerical methods applied. So did you apply Euler's method, Runge-Kutta? Is it Monte Carlo simulation? So which of the methods did you apply? Then you also want to provide a justification for the choice of software. And then you want to detail the accuracy, the industry standards, and efficiency. Okay? And after this, you also want to move up to discuss the simulation setup. Now you've been able to document this. Now we want to go into the setup and the execution. Okay? And don't forget, it's also in this session, you provide the algorithm. You want to put up the flowchart. You also want to put up the pseudocode, right? So once we are able to see the pseudocode, then anybody could use any programming language to achieve whatever they want to achieve. So another subsection will now be on simulation, setup, and execution. So you want to document the input parameters and initial conditions. So here you define the key input variables, such as the material properties, the environmental conditions, the applied load, depending on what you're working on. So here I mentioned input parameters and initial conditions. Then the next thing is the computational environment. Where you provide details on the hardware specifications, okay? The CPU, the GPU, the RAM, tell us the specification, and then you have to justify the choice based on the simulation speed and data size, okay? Because we don't want to, you don't want to use the particular CPU specification that will slow down the computational process. So you want to provide these details. Now, you may want to provide information about parallel processing or high performance computing if it applies, okay? So you want to really mention everything about the simulation setup, the version, whatsoever it is of the software and all of those requirements. And then you now move on to data processing and analysis. So this is where you now have to explain the data extraction techniques, okay? And you have to provide some details. You have to discuss how you were able to clean up the data, the post-processing, the interpolation technique you use. Then you have to also discuss some of the error minimization strategies you use and the convergence test in your data processing and analysis phase. And then you now move on to validation and benchmarking. So this is where you now compare your computational results with experimental data of previous literature. So, well, this is different from what you will do in results and discussion. Okay, so you are literally comparing the technical details of your developed algorithm or model with existing models. Okay, so we need to see some of those simulation parameters, the technical details, how yours is different and how it will optimize the system. Okay, so this is very important. Okay, because you have to now benchmark your proposition with existing solutions. So you want to look up what already exists in the industry, what exists in the literature. Then you now have to perform sensitivity analysis to check the stability and all of that. Then the final thing you also want to do here is ethical consideration, all right? So here we want to ensure transparency in model assumptions and limitations. So you want to also comply with data privacy regulations if you now have to deal with the real world, if your solution is going to, interface with humans. So let's assume you conducted your research in human-to-human communication technology, okay? Or machine-to-machine, for which humans will have to interface, okay? And then you provide a summary like we did in the experimental design model, So you want to provide a summary of the computational methodology and also highlight some of the key validation steps. So any questions so far before I run through methodology for design-based research? That should not take us another 10 minutes. Any question, please? Any question? Richard?
Yes, sir. No, I'm fine with it. I've seen the difference that you highlighted. This, yeah.
Okay, that's fine. So we now move on to methodology for design-based research. So this will apply to your mini project. So we'll also start off with the research design and approach, where we have to explain, I'll just put this down. You want to explain the engineering design cycle adopted for the study. So did you use the waterfall model? Now, is it an iterative model? So in this case, in the waterfall model, you want to follow a sequential design model, or are you particular about continuous improvement? So you want to tell. So you also want to mention the design philosophy. So now, are you? Is it interpretivistic? Is it? Are you positive? Yeah. Do you belong in the positivist school of thought? And so you have to also look up the design philosophy that will guide your research. Okay. So once you provide this detail, then you can now move on to system design and architecture. So this is where you provide the conceptual design framework. So here you want to provide the block diagram and system workflow. You also want to describe the functional and performance requirement. So let's assume you want to design a solution that we have a microcontrolling unit and we interface with some kind of sensors, microcontrolling unit, and then depending on the number of sensors, then probably this is also going to interface with some kind of database and all of that. Now, this is where you provide the schematic or the block diagram of your design, okay, under the system design and architecture, because that's where you begin. So now the subsystems should be clearly established in the block diagram. Does that make sense?
Yes, sir.
Yes.
And afterwards, you now move on to the component selection. This is where you want to justify. Now, this is not, I think we need to get a little guidance here. You don't want to begin to mention and discuss the components. Oh, resistor. A resistor is this. Capacitor. No. You literally want to provide the justification for your choice. So you want to justify the hardware and software choices. Okay? So here you want to provide a justification for your choice in terms of using the microcontroller, the type of sensors, the type of actuators, now the communication module, you are literally providing the justification for this, the material selection for the structural part, then the software framework for the embedded programming, okay? So you are providing justification for the software framework for embedded programming. So it's not time for you to lift the picture of your microcontroller and then begin to talk about microcontrollers. No, we are not interested in the details. If we want to know about the microcontroller, we could go to the data sheet. But now you are literally providing the justification for your choice in the component selection phase. Then once you're done with that, still in this session, then we want to look up the system integration and prototyping subsession. System integration and prototyping. So this is how this is in this session you now describe how different subsystems interconnect. Okay, recall you provided an architecture and just put up your discussion. But this time in this system integration and prototyping subsession, you now want to describe how different subsystems interconnect and interact. You also want to provide the circuit diagrams, the PCB layout, the fabrication details, and here you also need a little guidance. You don't just want to provide some theoretical details. You are going to be providing some derivations. So when you put up your circuit diagram, you are going to be performing your circuit analysis. It's not good enough to say, well, you use Proteus to just design and simulate. Then we want to see you play with your fundamentals of electrical engineering discipline to derive these things. How did you come about the value of the capacitor you used? So you have to show the system of equations, how you were able to come up with that calculation, technical analysis. Okay, now the fabrication details is going to be technical. Okay, so this session requires some level of computational analysis. Okay, so once you put up your circuit, then you are going to be performing your circuit analysis. So you have to do all of these things. Okay, now they will be included in the system integration and prototyping phase. So when you're talking about how a subsystem or a subunit interacts with another subunit, you are not just talking like, you are not talking literally. You'll be talking in terms of the voltage response, the the particular theory or principle behind that interaction. And should that principle or theory not be in place, what will happen? So it's more like technically describing what is going on here. And if the voltage level is 2.8, how did we get to that? So you have to tell the component that led, that provided that particular response and how that value was evaluated by that component. Does this make sense, please? Rachel, is this
Sure.
correct? Okay. So once this is done, then you can now go on to explain how the components are either manufactured, assembled, or integrated. Then you also want to mention the PCB fabrication process, okay, the 3D printing and the machining steps and all of those. So this is a pure technical description. So that if I should pick it up, then I should learn circuit analysis from this session. So you're going to detail and provide the step-by-step where you applied Thevenin's, you have to mention and show how it was applied. Where you applied Ohm's law, you have to mention it, that you applied Ohm's law and tell how it was and show how it was applied. You are literally performing that analysis. Did you apply Kirchhoff's laws, either Kirchhoff's voltage law or Kirchhoff's current law? Then you have to show it. You mention that this is used and then you derive it. And then we now move on to another session, the implementation and development session. So we start with the hardware development. So you want to describe the circuit design, fabrication, and assembly steps. You want to provide the PCB design schematics. You know, you mentioned that earlier, but now you are providing the schematic, right? The schematics. That's your PCB. Okay. If it's applicable, and then probably use some software to generate the pictorial view of the particular microcontroller and all the sensors and all of that to see in terms of emulation. Then we want to see those things here. And then you want to talk to it, how you came about that, how you were able to say, how you selected those parameters and all, so that if you use Proteus, for instance, then by mere reading through this session, let's assume I have never used Proteus before. Then should I install Proteus? Then the step-by-step approach as to how you started the process, how you open up the file, how you did this and that, the details should be there. So it's more like a guide this time. You are not teaching me how to use it, but you are literally telling me how to use that particular tool to achieve this particular goal. So that if I should follow the step sequentially, then I should be able to replicate that idea without having to look up another resource. Is this clear, please?
Yes, sir.
Yes, sir.
And then we now move on to the software development. So here you want to describe the firmware and the embedded systems, okay? Development. So you also want to describe the programming languages, the development platforms, and then how you went on to do that. So let's assume you had to develop a database in your, so let's assume it measures the sensors measures the data, and then it populates a particular database and then transmits to an app. So what applications, what platform, how did you go about designing the front end, the back end? So the programming languages or language you used, and all of that. Did you use Node.js? Did you use JavaScript? Did you use Java? So you want to mention these things and how it was done. Because the idea or the goal about your documentation is to be able to replicate this should someone else attempt to pick this up. And with this done, you can now move on to testing, another session on testing and performance evaluation. So this is where you conduct your functional testing. So you want to verify whether the prototype meets design specification, okay? And then you also look up performance metrics. So this is where you want to describe some of the key evaluation criteria: power consumption, accuracy, latency, durability. So depending on what you're working on, that will determine the metric that you'll be considering. Then you also want to look up comparative analysis. Where you want to compare your prototype's performance with existing technology. And you know, when we talk about existing technologies, we have what is commercially available. And then we also have what is available in the literature. So these are also prototypes. Okay. And then you want to compare. So why should we prefer your proposition, your proposed prototype? So why should we prefer your proposed prototype when compared with existing prototypes in the literature or with the commercially available device? Probably this is too expensive, probably they are bulky, probably you just decided to develop a wearable device that is cost effective, you know, probably the accuracy level, sensitivity level, it depends, okay? So you now have to provide that justification when performing your comparative analysis. And after this, you want to look up another session on optimization and iterative design. Okay, I'll say iterative design improvement. Okay, so I want to improve this. So you want to describe now, after conducting your research, you have to test it. Okay, so what happened after testing? So it means that the before testing, that's pre-test activities have to be documented. How did your device perform? So after testing, was there any need for calibration? So you have to mention, so you want to explain the strategies for efficiency improvement. So what did you do after testing to improve on your design? So you want to mention all of those details. Then afterwards, you come up again to discuss the ethical and safety consideration. Oh, just missed that up. Safety considerations. So once again, you want to ensure compliance with relevant standards. We have the IEEE, the ISO, then you want to address data security and privacy. Now, if it's going to be a wearable device and we have sensors, hope it's going to be non-invasive. So you want to look up those things and all of those, and then you now provide the summary of the chapter, where you summarize the key design and evaluation aspects. Okay, I think now, is this good enough to kickstart your chapter 3? So we can all unmute our microphones now, okay? Just for another 5 minutes interaction. Can we all unmute, please?
Okay, sir.
Yeah, so let's share our thoughts. So how do you see this? Were you having this in mind before now, or is something going to change after now?
No, no problem.
Go,
They're just selected for
go ahead, Rachel.
for me, like just going through it now, there are a lot of insights. I never really thought of it or saw it in this light, especially this last design and design methodology,
Okay.
design. So it's very, very important. Thank you.
Okay, you're welcome. So any other thoughts from anybody? Can see Olapo.
Yes, I have a little suggestion.
Okay, go ahead, please.
Maybe if we can lay our hand on some of the projects you supervise so that we'll see maybe if all these steps has been followed on how we can even correlate it with our own. I don't know.
Okay, I
Maybe a
think
project.
that's possible. You want to look up what we have in the library. I'm sure the department have a way of archiving them. And you have access to the library or the departmental library. So they should have them, they should have copies. Okay? And
Okay, sir.
the most important thing now is that you have me with you. So should you have any questions, you should ask. You could ask me. Okay?
Okay, sir.
Mhm.
Sir,
Go ahead, please.
my own I was just looking at the explanation on the mini projects. That's the methodology designed research. So the way you go through the process of explaining to us, it's really showed that our design, that means what we are going to implement, it's not going to be like a small design for us to implement. That's because I was actually proposing a breadboard presentation that is going to be on a breadboard, not
That's
really on
fine. That's fine. That's fine. You could leave it on a breadboard. But having a PCB design is optional. But you could, if you use some of the softwares, you could also get the PCB equivalent of your circuit model. So there are so many simulation or emulation platforms where you are able to generate the PCB design.
Okay. So definitely, if I'm going to do my on the breadboard, I could just get a PCB simulation for the design just to highlight it with what I have done.
That's one thing. And if your design is such that we need to have a PCB, why not? You could print it also.
Okay.
Yeah.
Okay.
Yeah.
All right. Thank you, sir.
You're welcome. So any other thoughts? Okay, so I think for now we'll call it a day and hope to see you in our next meeting. So bye for now.
Bye.
Bye, sir. Thank you.
Okay, bye, sir.